In this short video lecture, we will be looking at the orbital energies for multi-electron atoms. We will be looking at how the periodic table can help us determine the energy level order. So I'm going to quickly sketch out the skyscraper model of the orbitals found on page 53 of your textbook. So this again is called the skyscraper model, according to your author, Dr. Zoval, in his textbook. So I'm going to label these. These each refer to orbitals. So I labeled the 1s, the 2s, the 2p, the 3s, the 3p, the 4s, the 3d, the 4p, and the 5s orbitals, going from lowest energy to highest energy. So we have to remember what these orbital names, what it means. So let's start with the s orbitals. Okay, so what does it mean to be an s orbital? Well, it has a spherical shape. And so we would draw a circle to represent that spherical shape for 1s. And when we say 2s, it's going to be a little bit bigger. And we say 3s, it's bigger, and so on and so forth. So then the p orbitals, those have a different shape. And those what we sometimes refer to as a dumbbell shape. So this one that I just drew is along the y-axis, so I'm going to call it the 2py orbital. There's another orientation along the x-axis, which is the 2px, and a third orientation along the z-axis going in and out of this paper here, or the board, 2pz. So then we have d orbitals, and I'm going to draw one of the d orbitals here. We call it like a cloverleaf shape, and there's actually 3 others for 4 total that have this shape, but they're in different orientations in 3-dimensional space. So there's a total of 4 that have that cloverleaf shape. Again, they're in different orientations in 3-dimensional space. So there's a 5th one that looks a little bit different, so I'll draw that here. It kind of looks like the p orbital, but then it has like a little disk around the middle. So that's your 5th d orbital, so 5 total. And so actually the number of boxes I used in my diagram, the skyscraper model, to represent the orbitals refer to the number that there are. So there's 1 each of the s orbitals, 3 each of the p orbitals, and 5 each of the d orbitals. That's why there's those number of boxes. Okay, so we're going to use this to fill up the electrons for an oxygen atom. So we look at the periodic table and we see oxygen has 8 electrons. So we're going to fill up our orbitals from lowest to highest, which is the off-bow principle. And in each box, which represents orbitals, we put 2 electrons. So notice here for the 2p, I filled each box before I started pairing them up. And remember, that is Hund's rule. So we can see that we have 2 electrons in the 1s orbital, 2 electrons in the 2s orbital, and 4 electrons in the 2p orbital. And those, if we count the arrows, add up to 8 arrows. The arrows represent electrons, and oxygen has 8 electrons. So let's do another example. Let's work on titanium atom. And titanium has 22 electrons. So we're going to put 22 arrows to represent electrons in these boxes. So off-bow's principle says we start with the lowest energy and we fill up. So I'm filling up those electrons just like I did last time. But last time I only went to 8. Now I have to go to 22. So I keep filling them up using Hund's rule here to fill up the 3p orbital. And then we do 4s, which gives me 20 electrons. And now 3d, I need 2 more to give me 22. You need to know the order that these orbitals go in from lowest energy to highest energy from 1s to 5s. And there's actually an easy way to do this with a tool that you'll get on your exam, and that's the periodic table. So using the periodic table, we can come up with this order pretty easily. So we have the s block on the periodic table, which I'm going to shade in pink. And so s block refers to s orbitals. And we know that each s orbital can hold 2 electrons. So essentially 2 columns refer to the 2 electrons that fit in the s orbital. P block refer to the p orbitals. So 6 electrons fit in the p orbitals because there's 3 different p orbitals and 6 total electrons fit in there. So if we count the columns I'm shading in, it comes out to 6. So here's our P block I'm shading in orange. Just notice actually helium is part of the S block, but the rest there are part of the P block. And then the D block refers to d orbitals being filled. And here, d orbitals, there's 5 d orbitals times 2 electrons in each, means 10 different electrons. And so that's why if you count here, I'm shading in 10 different columns. Okay, so this is kind of, the periodic table it shows how the orbitals are filled. Okay, so what we're going to do is once we know this, we can do something that I call walking the periodic table. We're going to walk the periodic table from left to right, and that will tell us the order of those orbitals from lowest energy to highest energy. So we're going to walk from left to right, starting at hydrogen, going to helium, and then going across the next row and the next row. Okay, and the next row. We could keep going. You guys only need to know to 5s, as I'm going to show you how we know how to get from 1s to 5s. So I'm going to label here that we're filling in 1s, starting in the S block, then the next row, 2s, and then going on to 2p as we walk across. Then in the next row, 3s. I'm going to write that again. And then we walk across and we fill in 3p in the P block. We go to the next row, 4s. Here we come to the D block. So we fill in actually 3D. So that's one thing we have to remember. It's not 4, it's 3D. And then we fill in the P block, 4p, and then finally down to 5s in the S block. So we're going to look at an example. We're going to look at oxygen, just like we looked for the skyscraper model. So oxygen atom, I'm going to go ahead and circle it on the periodic table. There it is with 8 electrons. So walking across, starting at 1s, then going to the next row, 2s, then going to the P block, 2p. And then we're stopping because oxygen is in that second row in the P block. So that's 2p. So I can draw the diagram like we did last time, right? And so we know, again, using the periodic table, 1s first, then 2s, then 2p. And then we would put our electrons in like we did before. But I'm just giving you a tool of how to figure out that order. So like we did last time, let's change to titanium atom. Okay, so titanium is number 22. So walking the periodic table, starting with 1s, 2s, 2p. Then we go down to 3s, and then I need to draw 3s in there. Oops, let's label it to the side, so 3s. So then we go across to 3p, right, because we haven't made it to titanium yet, so we go across to 3p. So I'm going to draw in my 3p orbitals. So that's 3 boxes representing the 3 different 3p orbitals. We're not done. We go down to the next row, row 4, where we're filling in 4s. And then we go over, and now we're filling in 3D. So I'm going to draw my 5 boxes to represent the 5 3D orbitals, and we're filling in the 3D orbital. And that's it in this case, but if you had an element over in the P block there, you would fill in 4p, and then if you go to the next row, 5s. So bottom line is you can know the order from 1s to 5s using the periodic table, PT periodic table, to help you. So you fill in, if you're in row 1, we got 1s, and then we go to row 2, 2s, and 2p, row 3, 3s, then 3p, row 4, 4s, and then you got to subtract 1, so 3d, and then 4p, and then 5s. So really the only little tricky thing is just remembering that d orbital is 1 less. The number is 1 less than the row that you're in. So hopefully that'll help you know the order for filling up those orbitals.